Hello, calculus students. Welcome back. We're going to be looking at lesson 8.4, area between curves with respect to x. Now, I want you to look at your notes, and I want you to notice from the title, we can see that we're going to be working with multiple curves. It says area between curves. So that means we're going to be looking at multiple functions. We know how to find the area under a curve. So in today's lesson, we're going to be looking at more than one curve to be specific, okay? So let's recall a couple things. When we find the area under the curve of f of x, let's say for example, I have this graph that goes something like this, right? To find the area under the curve, I'm looking at all this area right here, no? All the area under the curve. Obviously, if it would be restricted to -1. But let's say I have my first curve, and now I introduce a second curve. In this case, that second curve, let's make a parabola. Let's say that that's my parabola. In today's lesson, we want to find the area between these two curves, between these two graphs, okay? So that's what we're going to be looking at in today's lesson, okay? So how would we find such an area? Well, luckily for us, the integral bounded between some value a and bounded between some value b is going to be our first function, f of x, minus our second function, g of x, where f of x is going to be called the higher curve and g of x is going to be considered the lower curve. And we got to figure out which one's higher, which one's lower. In this case, this top one is higher, so we would call this one f of x. And the parabola, since it has a lower part, this one would be called g of x. Okay? Now, we got to keep in mind that in order for us to take the area in the interval, we have to keep in mind that f of x, again, this goes back to me saying higher or lower, f of x has to be greater than or equal to g of x for this condition to meet. So in this case, f of x is higher because it runs through the top than g of x because g of x runs through the bottom, right? All right, so that's the first thing we want to understand, okay? So let's move on to the next part. Let's look at question 1. Find the area bounded by the curves of y equals x squared plus 2 and y equals -x, where x is equal to 0 and x is equal to 1. That gives us a lot of information. We have to set up our integral. How do I know which one's top, which one's bottom? I see just that for this first one, I have y equals x squared plus 2. That means it's a U shape or a parabola that's been shifted up by 2. So that's this one right here. That's my first curve. This is going to be f. And then my linear, -x, this is going to be g. Using my formula from above, I can say that I will do my integral. And it's bounded between 0 and 1 because they tell us that x is 0 and they tell me that x is equal to 1, right? So my integral is bounded between 0 and 1. My first function is x squared plus 2 minus -x. Uh-oh, my computer might be lagging again, so if I have to break up the video, I'll break up the video, okay? And then everything is with respect to d of x, okay? dx. Now, let's go ahead. We can simplify these, put them together. So this is going to be bounded between 0 and 1. I go ahead, combine these two. I get x squared plus 2 plus x dx. Okay? So now I take the antiderivative. That's going to be x cubed over 3 plus 2x plus x squared over 2. When we're evaluating to the limit between 0 and 1, or we're evaluating between the bounds of 0 and 1. So now I plug in the 1. I'm going to get, so this, I'm going to do the work up here. This is going to be 1/3 plus 2 plus 1/2. I'm going to put this all in parentheses, right? And then we're subtracting. Well, I'm subtracting because I plugged in a 1. Oh, my mouse isn't working now because of the, you see these little bubbles? These little bubbles indicate that my computer is glitching. But anyways, let's finish this part so that way I can continue. I plugged in the 1 and I got 1 to the power of 3. That's 1 to the power of 2. That's 1. So I got 1/3 plus 2 plus 1/2, right? Minus, if I plug in a 0, well, this is going to be 0. This is going to be a 0. And this is also going to be a 0. I'm plugging in the 0 right here to this equation. So now if I plug in a 0, it's going to be minus 0, right? So now I want to make everything in terms of each other, like in the same denominator. So the greatest common factor is 6, because 3 times 2 will give me a 6. So I want to make everything in terms of a 6. So I got to multiply the top by a 2. I have 2 6 plus, what is this, 12/6 plus 3/6. I add that together and I get 17/6. So my area is 17/6 units squared. Boom. And that's the area underneath the curve between this interval. So if, let's say my interval is between 0 and 1. I found the area of this chunk right here. That's the chunk that I found the area of. Okay. All right. Let's go ahead and do number 2. It says find the area bounded. Find the area bounded by y equals x squared and y equals x. I don't have a graph. I don't know how this looks, but let's see. If I have to think about this, let me just draw a quick little sketch. So I'm going to do a little sketch here on the side. You can do your little sketch here. Again, this indicates the positive sides. A negative x squared, that means it's facing down. 2, that means it's up at 2. So at 2 right here, this is my parabola. This is where it starts. So my parabola heads down this way. My parabola heads down this way. Now, my line is y equals x. So I know my line is going to intersect here through the center. And it's going to go this way. Right? So that means I have an intersection here and some intersection here. I want to find the area bounded in this chunk right here. I want to find this chunk. Quick little sketch right there. Okay. Now, from right here, I want to know what are my bounds for my integrals. So how can I find the bounds for the integrals? I wasn't given the bounds like in the previous one. So in order for me to find the value of x, I'm going to go ahead and set both functions equal to each other. So I'm going to say 2 minus x squared is equal to x. I'm going to go ahead and move everything to one side. In this case, I want to make sure that that x squared is positive. So I'm going to move it from the left to the right. So I'm going to go ahead and say, whoops, 0. Come on. Uh-oh. Come on. All right. So where is my stuff? I guess you had the graph. So if everything wiped, rewind for a bit. But where was I? So I'm going to have -2. Sorry, not -2. My apologies. So this is what I had before. I had 2 minus x squared is equal to x, and then 0, because again I'm shifting anything from the left to the right. So I'm going to be x squared. Now it's positive, plus x minus 2. I just rearranged everything so it looks like a quadratic. Use the x method to factor that, and you should get that 0 is equal to x plus 2 times x minus 1. Boom. Now I'll solve for x on both sides, and I get that x is equal to -2 and x is equal to +1. Now I know where my graph is going to be bounded between for my integral. So now my integral tells me that I'm bounded between -2 and 1 for my function. In this case, it would be 2 minus x squared minus x dx. Again, I know that my top one was a parabola, so that's why I put this as my f of x, and this is my g of x, right? I just put it all together. I grouped it all. This is from our initial formula from the very top, okay? So I grouped it all together. That's how I got that. All right, from here, I just evaluate it. You know how to do this on your calculator. So I want you to grab your calculator and practice typing the integral. So the integral between -2 to 1 of my function 2 minus x squared minus x dx. Type that in, evaluate it, and you should get, what do I get, y'all? What do I get? Give about 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So you should have typed this into your calculator, and you got, make sure you pause the video, obviously, before you type it into a calculator. So I'm just dragging it on purpose. But you should have gotten, if you typed it into your calculator, 9/2, or 9/2. So the area under the curve is 9/2. Okay. So I'm going to go ahead and say that we are going to move to the next one. Let's see. Hopefully it allows me quickly to move on to number 3. Set up the integral that allows you to find the area in the first quadrant that is bounded above by y equals the square root of x and below by y is equal to x minus 6. Sorry, I'm trying to zoom in as best as I can without getting rid of my work. Okay, so let's look at the last one. The last one is tricky because the top is bounded above. So this is very important. Bounded above by y equals the square root of x. If I know what my function looks like, this is just some little side work to show you why this is important. The square root of x is just a graph that looks like this. But no negative values exist for the square root of x, right? Because if I take the square root of 36, I'm going to get 6. If I take the square root of 100, I'm going to get 10. I'm going to work with just the positive numbers. I cannot have negative values when I take the square root of a number, right? If I do, it's going to be an imaginary number. But we're not trying to work with imaginaries. So for this graph, everything is just bounded between the x-axis and my graph, right? But now it gets interesting because now I have this linear line here. This linear line throws things off because now this chunk right here, it doesn't have nothing there. There is no area under that curve. So this is where I have to break things up into 2 different sections. There's a difference between finding the area for the left side versus the right side. Okay, for the left side, I can just go from 0 to 6, and I will only just focus on the square root of x, right? Because the linear line is on the negative sign. I can't even look at that information, right? So for my first integral, I'm going to go ahead and say that it is bounded between 0 and 6, and the only function I'm going to be looking at is the square root of x and dx. But now, plus, I have another chunk from 6 to 9, because that's between those 2 curves now. So now I'm going to take my integral from 6 to 9, and now I get to plug in my formula. In this case, I still have that the square root of x is on top. So I'm going to do square root of x is equal, square root of x minus 6 dx. Boom. And that is it. They do not tell me to solve. They don't tell me to plug anything in. That's how you generally find up the area of a bounded space that is restricted by the x-axis, the linear line, and some other line that we have no idea what it is, okay? Let's see. I want to end the video for now. Let's see if I can make it to work. Come on. Let's see. see.